Students, let us have a quick revision on the Ellingham diagram. So in the last lecture we have learned that for any reaction to be possible in nature, delta G has to be negative. And please remember, more the negative value of delta G, easily the reaction can occur. Less the negative value of delta G, less easily the reaction can occur. And if delta G is 0, the system is at equilibrium. Now what you call it as an Ellingham diagram is basically a plot of delta G versus temperature in the Kelvin scale. So how does a graph look like? Talking about the very first line, it is the formation for carbon monoxide, and as you can see, as the temperature increases, the formation of carbon monoxide graph is sloping downwards. On the other hand, this is the formation of carbon dioxide, which is seeming to be independent of temperature, which is almost parallel to the temperature axis. And go to the next one. This is the formation of carbon dioxide from carbon monoxide, and the graph is sloping upwards with the increasing temperature. Now this entire Ellingham diagram is all about the metal oxide. Yes students, this Ellingham diagram is like a Bible in the metallurgical industry. So talking about the metal oxides, let us see how the graph goes. For example, the first one is the formation of magnesium oxide, and as you can see, at a lower temperature, delta G value is very low, but as the temperature increases, delta G value is becoming less negative. On the other hand, this is the formation for alumina. It goes the same way. So the temperature increases, the delta G formation keeps on becoming less negative. Same with zinc oxide and iron oxide, and this is mercury oxide. So for all the metals, only at a higher temperature the delta G was less negative, but for mercury oxide, even at a lower temperature, the delta G is very less negative, and same goes with the silver oxide. So please remember students, what you call it as an Ellingham diagram actually looks like this. And the kind of question that can be asked based on the Ellingham diagram is this. The very first question is, what are the features of Ellingham diagram? So we need to memorize the features, talking about the very first one. So the graph for the formation of a metal oxide is a straight line with an upward slope, as you can see. And obviously for carbon monoxide it's coming down, but that's not a metal oxide, that's a non-metal oxide. So that's the first one. The second point is, there is a sudden change in the slopes of certain metal oxides, like, take a nice look at the graph over here, magnesium oxide, and for zinc oxide, and also for mercury oxide, which is over here. Well, that is the second feature. Now what is the third feature? For few metal oxides of mercury and silver, which is at the top over here, and these graphs are placed at the upper part of the Ellingham diagram. Going for the fourth feature, the graph for the formation of carbon monoxide. Take a look at this part. So the graph for the formation of carbon monoxide is a straight line but with a negative slope. And talking about the fifth feature, the graph for the formation of carbon dioxide, which is this one, and as you can see, it's a straight line which is parallel to the temperature axis. So these are the features of Ellingham diagram. Now the next question that they can ask you is, what are the significance of Ellingham diagram? Significance means what can you understand from this Ellingham diagram? Let us have the first one. As you can see, the positive slope of the metal oxide over here shows that their stability decreases with increase in temperature, and this decrease in stability is due to an increase in their delta G naught value. That is the first significance. Talking about the second one, there is a sudden change in the graph of MgO, ZnO and HgO. Now the next question is, why there is a sudden change? Well, this sudden change actually shows a phase change. Phase change, which means conversion of solid to liquid or from liquid to vapor. Talking about the third significance, the negative slope of carbon monoxide over here shows that their stabilities increases with increase in temperature. Yes students, the negative slope of carbon monoxide shows that it becomes more stable when you increase the temperature. And the fourth significance is the tendency of the metal to undergo oxidation, or the tendency for the metal to take up the oxygen, goes in this order, that is magnesium, aluminium, zinc, iron, mercury and silver. That is, it goes from the bottom to the top. Now the next question is, why is this order maintained? That is because due to the increase in the negative of delta G naught value for the formation of oxide goes in the same order, that is from the bottom to the top. Well, these are some of the significance of the Ellingham diagram. Now the kind of question that can be asked is this: which of the following sulfides, when heated strongly in air, gives the corresponding metal? Obviously that has to be a very unstable oxide, so the right option would be mercury or silver. So in this case, the right option is D, which is mercury. Second question, delta G naught versus temperature plot for the Ellingham diagram slopes downward for the reaction. The right option is for only one graph, that is for the formation of carbon monoxide. Go to the next question. Consider the following reaction at 100 degrees Celsius. First one is the formation of zinc oxide. Second one is the formation of carbon monoxide. And from the delta G naught value, I can understand that formation of carbon monoxide reaction is much more stable than the formation of zinc oxide. In this case, the right option would be option B. Why? That is because zinc oxide can be reduced by graphite. So zinc oxide in the presence of carbon will lead to the reaction where zinc and carbon monoxide can be formed. And as I can see, carbon monoxide reaction is much more stable. Hence, the B is the right option.